Okay, so now let's see how we can automatically adjust this ladder height instead of manually changing its value on the setup settings like this. Okay, because in your level you may have multiple different buildings where the ladders should be attached to, so you should not be like, I mean, it's fine to configure this stuff manually as well, but it's better to have some automated way to configure the height at runtime or the development time, so that it will be easy for you on the level design. Okay, so first maybe let's try to, what do you call, um let's try to add a building, right? So I'm not gonna go in deep for buildings stuff. Maybe just for the time being I'm gonna simply add a very basic shape, a cube. Okay, I just want to keep this stuff simple as possible for now, and later on we can maybe create some sample blueprint for buildings and stuff, right? But just for the time being I will add this sort of a cube, and you can see we have two different heights. Okay, right, and let's just say this ladder should go in here, and this ladder should go to here. Okay, now we have the ladders, we have the buildings. Now their heights should be automatically adjusted, right? So how we can do that? To do that, let's just go to the top, the ladder base, and at the event graph, I'm gonna create a new event called, let's just say, auto adjust ladder height. And this function should, or the event should be able to call on the editor. So make sure the call in editor is marked as true, so that once you click the instance, that will be available over here, right? So you can simply call the event directly like this, right? Now I will create another function as well by saying, let's just say adjust ladder height. Let's just say trace and adjust ladder height, and I will call that function over here, right? So now here, why I call it as trace and adjust ladder height, because we have to perform some line trace to detect the topmost location of the ladder. So in this scenario it is this location, and then based on that location we can compute the actual distance starting from the ladder bottom to this location, and that distance will be the height of the ladder. Okay, so that's the logic there. So in order to compute that, first we need to perform a line trace, right? So I will perform a line trace by channel, and the channel should be visibility channel, and now I need to determine the start location. So how can I do that? Right, for that let's add a yeah, at the scene exit, let's add a static mesh placeholder. Okay, so I'm going to call this one as sm underscore top placeholder. This is just a placeholder reference. Okay, and as the static mesh, I will assign a cube, default basic shape cube. I don't need this amount of scale. It should be 0.1 by 0.1 by 0.1. And yeah, it should be okay right now, and also it should be hidden at the gameplay, right? So at the hidden in game, make sure it is marked as true, so that this box will not appear on the runtime, right? This is just a placeholder reference that we can use to compute the height of the ladder. But right now you can see it is been on the bottom, but instead what we need is we need to move it up, right? Or we can do that. So to do that, I think we have to move up this entire scene up. So how we can do that? Right, to do that, at the construction script, configure ladder. Yeah, here we have the top exit part, and here I will take the reference for the scene exit and set its relative location like this, and maybe let's make a vector like this. And the C should be the ladder height. Compile, save, go to the viewport. Right, now you can see that placeholder has been gone up. But it still seems a little bit off. So at the top placeholder, maybe let's try to add a little bit of a offset, maybe 25. Okay, good to go. And a little bit out of this ladder, because you can see now it's directly aligned with the ladder. Instead, maybe let's give it x offset like -25. Okay, I think that's good to go. Right, right now we can use this top placeholder to make some ladder height computations, right? So at the trace and adjust ladder height. Now let's use that top placeholder. Also, one other thing to notice, that at this top placeholder, at the collision preset, make sure it is no collision, right? So that it will not collide with the actors, dynamic actors, or any other static actors. Okay, right, now let's get the actual world location of this actor and break it like that. And at the start, I'm gonna make a vector again. X and Y is same, but the Z value should have add some offset. So I will promote this to a variable called ladder height trace distance, which is a private variable, and maybe I will give it a very large value like 10,000. and it will add this offset over here. And similarly for the end position, let's make another vector. X and Y values are same, but the C value should be the minus value, subtracted value, like this. Okay, so just for the time being, I will enable the trace for duration, so I will be able to see the trace. Right now, if I go to the level, click the ladder and click this function call, right now you can see the trace has been performed and it will detect the location over here, right? So you can see there is a hit point. Okay, then what I can do is, here if we have a hit, then I'm gonna take the hit results, and at the impact point I'm gonna compute the distance starting from the bottom location of the ladder. So the bottom location placeholder, we can use this one, this arrow, because it is at the bottom. So let's take the arrow, get world location, and the distance is basically the relative locations of these points, impact point and the arrow world location, and ideally that is the ladder height. So I'm gonna reconfigure the ladder height directly like this over here. Okay, and after that, this is the tracing actually. I will add a comment called calculate ladder height by using a trace, using a line trace. And once computed the ladder height, you can generate the ladder again. Compile, save. Go to here. Now let's click this button again. Right, you can see the ladder has been generated automatically and the height is adjusted, as well as this been added like this. But it has been gone up a little bit further than it used to. What I can do is yeah, let's promote a new variable called ladder top offset. Again, this is a private variable, and maybe I will assign a value like 50 by default. And here, let's subtract this top offset. Maybe let's add the top offset, and I will make the top offset as -12. It should be much more convenient, and attach it back to the ladder height. Compile, save, and generate it again. Right, now you can see it's better. Maybe -50 is too much. How about -40? Better, right? Now you can see the height is a little bit good. Okay, so that is for the pipe ladder. The same thing goes to the box ladder as well. So we don't need to implement these functions again and again, because these are at the base class of the ladder, which means that by default the logic will be inherited for any other child instances. So these are the child instances, pipe and box ladder. So they will also have that specific functionality by default, right? So you can actually verify by going to its category settings section. You can see the auto adjust ladder height is there. If you click it, automatically the ladder height has been adjusted. Okay, and I think we can disable that ladder height as well. So what I'm going to do is I'm going to create a new variable called debug ladder height trace, which is a boolean. So I need to set up category and maybe add a subcategory called debug. Mark it as a public variable. By default it is false, and here at the line trace debug type, let's make a selection based on that boolean. If the boolean is true, I am performing for duration line trace, otherwise it is none. Compile and save. Now if you try to click the auto adjust ladder height, it will not show you the trace. But if you go to the setup and the debug section and enable this debug ladder trace height and try to auto adjust the ladder height again, now you can see that trace over here. If you disable it again, you can't see it anymore. Okay, that's a small improvement that I added for the ease of debugging. But anyway, now you can place any type of a ladder and it will be adjusted to the appropriate building height. So for example, let's just say I move this ladder to here and click the auto adjust ladder height, it will be automatically adjusted, right? Also if I move it to here, auto adjust ladder height, again it will be adjusted. Right, so that's how we can adjust the auto adjustment for the ladder. Now I think we have a pretty good procedural ladder, but later on we need to do some improvements as well. For example, like whenever the character is trying to interact with the ladder, maybe we have to do some implementations for the ladder. But overall, now we have a very good setup. Right, so before winding up this section, maybe let's try to add some sample grid materials to these meshes and the landscape, so we'll have a much more better visualization for the scalings, right? So if you go to the ladder system essentials materials directory and Lyra starter materials, I have added some placeholder materials which are grid materials. So you can use these grid materials instead of this default checker material. Okay, so I'm going to select this landscape and select this MS blue material and assign it to here. You can see we have that grid over here. And also for these cube buildings, I will use this MIMSFS1. Now we have a better visualization. So this having a grid material is a real benefit, because you can see these grid are world aligned, so that you can easily figure out the locations and the scalings, right? So maybe like if you make it 6, you can see there are exactly 6 checkers, right? And maybe if you make it 10, adjust the location correctly, and yeah, now the alignment is perfect. You can see those stuffs are there, and we need to adjust the ladder a little bit off like this and click the auto adjust ladder, so they will adjust the ladder height. Right, now we have a better overview, right? The landscape is having a material and these buildings are also having a material, so it will be better for scaling later on. Okay, so that's it for this section. So now we have a procedural ladder setup. So the next section we are going to cover the main section of this course, which is ladder movements. So let's see how we can implement those movements in the next section. I'll see you there. Thank you.